So we need to imagine that we have this town consisting of electrons, and these electrons go jogging at this park that's in the town. And this park has certain tracks that the electrons go jogging on, and these are the rules of the park. There are many, many tracks, but only 2 electrons are allowed on any track at any one time. Now later on we're going to call these tracks orbitals. The easier tracks fill up first. The easier orbitals fill up first. In other words, these electrons, when they go jogging, they want to get in shape, but they don't really want to work harder than they have to. So the easiest tracks are going to fill up first. Some of them are easier than others. There are S tracks, or S orbitals, and we can think of these as being on level ground. And they're circular in shape. Another type of track we're going to call P tracks, or P orbitals, and these are figure 8 shaped, and they're on rolling hills, gently rolling hills. If you've ever done any jogging, you know that jogging on rolling hills is a little tougher than jogging on level ground. There's one other type of track that we're going to meet in this analogy, and those are the D orbitals, and those are shaped kind of like clover leaves. And running on a D orbital, you're going to go up and down steep hills. So D orbitals are quite a bit of work. Once an electron gets on an orbital, it's got to go around many times. Let's just say 100. You can't just go around twice and quit. The fourth rule is that all orbitals of equal difficulty must have 1 electron before any doubling up. And we'll discuss that on the next slide. And lastly, electrons on the same orbital, and then there can only be a maximum of 2, they must go opposite ways. In other words, the 2 electrons that are on the same orbital can't go jogging around together discussing, the game on TV last night. They can pass each other twice every go-round. And all they can say is, "Hey, what's up?" And then they're past each other again. So, it's early in the morning. Electron number 1 wakes up early, goes out to the park to do some jogging. He's going to take the easiest orbital that's available, and that's the 1s orbital. It's a size 1, it's small, and it's an s orbital because it's circular in shape. It turns out there's only one 1s orbital, so electron number 1 can go on there, and also when electron number 2 shows up 3 minutes later, that one can go on there as well. So we have 2 electrons going on the 1s orbital, going opposite ways, not jogging together. So we're going to indicate this by saying 1s2. In other words, in the 1s in the 1s orbital, there are 2 electrons. So I'm going to number them down there so we can keep track in the lower left of how many electrons we have. Electron number 3 shows up. He hit his snooze button once. He would like to get on the 1s orbital because it's the easiest, it's the lowest energy, but it's full because the 1s orbital can only hold 2 electrons. So electron number 3 goes to the next easiest orbital, which is the 2s orbital. It's also on level ground, it's spherical in shape, circular in shape, but it's larger than the 1s orbital, and since you have to go around 100 times, it's going to be more work to go on the 2s orbital. So there is, in this park, because of the way they built it, there's one 2s orbital, and electron number 3 goes on there, and when electron number 4 shows up, that one goes on there as well. So at the bottom of the screen you can see that so far we have 2 electrons in the 1s orbital and 2 electrons in the 2s orbital. Electron number 5 shows up. Tries to get in the 1s orbital, but it's full. Tries to get in the 2s orbital, but it's full. So the next easiest one is this orbital, which is a size 2. You can see it's a size 2, but it's a p orbital. This one is more difficult than a 2s because on a 2p we're running up and down gentle hills. It turns out, because of the way they built the park, that there are 3 of these 2p orbitals. So electron number 5 goes on to one, electron number 6 goes on to another, electron number 7 goes on to a third, because the rule is that all orbitals of equal energy have to have one electron before any doubling up. Well, once each of the 3 2p orbitals has a single electron, then they double up and can hold a total of 6. So down at the bottom of the screen, we're going to write 2p6. In other words, on the 2p orbitals, and there are 3 of them, there are a total of 6 electrons. In other words, electrons number 5, 6, 7, 8, 9, and 10 are all on 2p orbitals. So electron number 11 shows up. He hit his snooze about 3 times, looks at 1s orbital like an idiot, as if the 1s orbital is going to be available. It's not. So he looks at the 2s orbital. It's full. All the 2p orbitals are full. The next easiest orbital that's available is this one. It's a 3s orbital. It's circular in shape. It's on level ground, but it's big. So to go around 100 times is going to take some work. Maybe not coincidentally, there is a single 3s orbital. You might see a pattern here. We have a single 1s orbital, a single 2s orbital, and a single 3s orbital. So electron number 11 and number 12 both can go on the 3s orbital. Now they're running in opposite directions. So at the bottom of the screen, we write 3s2. That is, in the 3s orbital there are a total of 2 electrons, electron 11 and electron 12. Electron number 13 shows up, and the next easiest orbital that's available is this one. This is a size 3, but it's a p orbital. And because of the way they built the park, they built 3 2p orbitals. They also built 3 3p orbitals, which can hold a total of 6 electrons, because each orbital can hold 2. So down at the bottom of the screen we write 3p6. Electrons 13 through 18 are jogging around on the 3p orbitals. So here comes electron number 19. He hit his snooze about 4 times and read a little bit of the paper before he showed up, and the next easiest orbital that's available is this one, and I'm guessing that you can predict what this one is called. That's a 4s orbital. There's one of them. So electrons 19 and 20 can run around on the 4s orbital. Now, here's where something gets a little funky. Electron 21 shows up and tries to find the next easiest orbital. Well, the next easiest orbital is this one, which is not an s orbital because it's not circular. It's not a p orbital because it's not figure 8 shaped. This is a d orbital. But it's not a 4d orbital, it's a 3d orbital, because you see it's more like a size 3 than a size 4. Now, you might ask, why would a 4s orbital fill up before a 3d orbital? A 4s orbital is larger. Well, recall that a 4s orbital is on level ground, and a d orbital is on steep hills. So it's actually easier to run a longer distance on level ground than a shorter distance on steep hills. Now I'm not going to draw all these in, but it turns out that there are 5 of these 3d orbitals, which means they can hold a total of 10 electrons. So electrons 21 through 30 run around 3d orbitals. Bear with me, we're almost done. Electron 31 shows up. checks the 1s orbital just in case it might be available. Of course it isn't. So the next easiest orbital that's available is this one. That is a 4p orbital. And just like previously, there are 3 of those, which means there can be a total of 6 electrons on those orbitals. And so at the bottom we write 4p6, so electrons 31 through 36 fit on 4p orbitals. There are other tracks, and all of these tracks are actually overlaid. They're all concentric. But what we're doing with electron configurations, and you can see at the bottom of the screen, is we're telling you where electrons are in an atom. We've got another lesson on this, so bear with me, but thanks for joining me today.